Okay, this video now is going to be a little bit of a review about perimeter and area, and then we're going to really focus on the circle, the circumference and area of a circle. Okay, to review, perimeter is a distance around a shape. It comes from the word peri, which we hear a lot with peripheral vision, which is like your vision around. So that means like around. And meter, you know, means to measure. So it's like the measure of around something. That's how you get that from. It's 1D, one-dimensional, and that dimension is length. And when it has a problem, like if you have to find the fencing, how much border, those are the kind of the problems that you need the perimeter for. Okay, a couple examples. Perimeter of a rectangle here. You add up all the sides. You have two, actually the actual formula for the perimeter of a rectangle, as you all know already, is twice the length plus twice the width. So twice the length plus twice the width. It doesn't matter usually which ones, like you could call this, the 3 could be the length, or it could be the width. It doesn't matter, and the 15 the width, as long as the one is the, one is one and one is the other. The answer there is 36. And then now that you're getting up in your grades, you're going to get something more like this. If the perimeter is 40, they're going to give it to you. You have to find x. Well, x, one side is x, one side is 4 times x. So you got to figure out, okay, put into the formula, perimeter is 40, and that's twice x, twice the length, plus twice the width. The width was 4x. And you just work it all out, 2x plus 2 times 4 is 8x. Combine like terms, you can circle them if you like. 2 times 4 is 10. So 40 equals 10x, so you divide by 10. Divide by 10, and I'll just write over here real clear. So 4 equals x. X is going to be 4 meters or whatever unit you're using. Okay, hopefully that's a little bit of a review. The next one we're going to talk about is area. The technical definition for area is it's the number of square units it takes to cover a shape. Okay, it's 2D, it's length and width. And you're going to have it in problems that talk about, they want to find out how much covering, how much wrapping paper, how much paint, how much grass maybe you need to cover a certain area. Anything that covers. Carpet is another one. Anytime you have problems with carpet, those are all going to mean you've got to find the area. Okay, an example. Well, here I don't have any examples. I have formulas. The area for rectangle, you know, is length times width. Square, that's a square, is s squared. And the way I got s squared was s times s, because that's the side, and the s stands for the side. Triangle is 1/2 the base times the height, and the trapezoid may not be as familiar, but it's 1/2 the height, and they'll usually always give you the height. The height is where you have that that box, which means that altitude, the perpendicular, and that would always be your height. And then the base would be the guys that are the two sides that are parallel. That's your base 1, and that's your one of them is base 1, and one of them is base 2, and it doesn't matter which one you have. All right, that's a quick review. Now we're going to talk now about the circle. To get the circumference of a circle. Is basically if you had a circle and you took a yarn or string that was the same length as the diameter, you could fit this 3 times around the circle, roughly, a little bit less than 3 times. So it takes a little more than 3 diameters to fit around the circumference. So the circumference is about equal to 3 times the diameter. And that's actually where we get the number pi, because in every circle it's about 3, it's exactly pi times the diameter is how much it is around the circle. So that's how we get the formula for the circumference is pi times d. We know the radius, the diameter is twice, 2 radiuses equal diameter. So we could also say the circumference equals 2 pi r. Okay? Pi is about equal to 3.14. And the way they get that is really 22 over 7 approximately. So when you go ahead and divide 22 divided by 7, you get 3.14. And you keep going. Remember, that's only approximate, and that's just the best approximation we have that we use in most of our problems. Okay, let's do a couple examples. A donut has a diameter of 3.5 inches. So you want to know what's the circumference. Well, you write your formula down first. And since they gave you the diameter, we're going to use a diameter formula and not the radius. You could, but you have to, cut it in half and then multiply by 2, which doesn't make any sense. So since they use fractions, we're going to use the pi that stands for a fraction. So we use 22 over 7 times 3.5. Well, the way you multiply fractions, remember, you have to get this as an improper fraction, which equals 7/2. Remember, 3 times 2 plus 1. And here you can go ahead and just take your reduce, okay? Right, 7 goes into 7 once, 7 goes into 7 once. 2 goes into 2 once, 2 goes into 22 11 times. So 11 times 1 is 11, 1 times 1 is 1, so you get 11 inches. If you didn't do that, you just do 22 times 7 and have to divide it by 14. And you could do that if you like. Okay, number 2, a clock has a radius of 5.5 inches. What's the circumference? Well, now we have radius, so we're going to use the radius formula. And we have decimals, so we're going to use the 3.14. So we simply write the formula down, plug it in, and we just get our answer. We just multiply to get our answer. Okay, now to talk about the area of a circle. the area of a circle, if you think about a circle, maybe take a paper plate or something, or a piece of paper that's a circle, and you fold it, and then you fold it again. If you fold it in half, you know that's the diameter. Well, if you fold it in half again, that's the radius. So both these are the radius. If you keep on folding it into wedges, then you're going to get shapes like this. Well, ideally, if you could get really, really skinny, mine's kind of thick here, but if you could really get really thin wedges, oh my goodness, really thin ones, you could really get a shape that's very much like a rectangle. If you can cut enough of these wedges and glue them all back together to make it look like a triangle, a rectangle. And if you did that, then this right here is the same as that part of the wedge, which is that part of the wedge, which is our radius. Okay? And all these little guys, these little round things, these little arcs we call them, basically, they're really, this part here, well, they're really part of the circumference. But it turns out this is only half the circumference and the other half is down here. And of course, the smaller you get, the more you make it look like a rectangle. So this is really, so now we have a rectangle. Well, what's the area of a rectangle? Length times the width. So we take that, r would be your length, and the width would be half the circumference. Okay, let's keep going. We have the radius, we have the half. Well, what is circumference? Remember, circumference equals 2 pi r. So, or we can take pi times d. We're going to use r here since we already have an r. So it's 2 pi r. We've plugged everything in. Then look what we can do. Well, half of 2 is just 1, so I don't really need to write that. And r times r is r squared. Oh, this got mixed up. So this now, the area then of a circle, that's how we get it, is pi r squared. And that's how you get it to be pi r squared. Thought that'd be kind of interesting for you to see. Okay, now we've got to do some problems with it. Okay, we're going to kind of mix up. Oh, actually, before I do the problems, I just want to make some general statements. Okay, what's in a circle? In other words, things to notice. And we've talked about some of these already. The diameter is twice the radius. So if you do the diameter to the radius, you'll get a ratio of 2 to 1. Okay, the circumference, remember, it says about 3 times the diameter. If you do circumference to diameter, you get pi over d, pi times d over d. Well, you reduce that, you can cross those out, right? Reduce them. You really get pi to 1, which is about 3. So the circumference is about 3 times the diameter. The area is about 3 times the radius squared. Again, if we got area to radius squared, we can see it's pi r squared is the area, and then over radius squared, so it's simply pi over 1 is a comparison to area and radius squared. Okay, let's do some examples. Example number 1. If the area of a circle is 200.96 meters squared, find the radius. Okay, so now, usually we're given the radius, find the area, but now we're going to have some different kind of problems. So our area is that. We plug it in, write down the formula first. The area, plug it in. We use 3.14 for pi because we already have a decimal, so just keep it to decimals, times r squared. So we divide both sides by 3.14. I didn't show that part, but you would divide that by 3.14, okay? And we get r squared equals 64. So then we know that r squared is going to be 8. I mean, the square root of r 8 times 8 is equal to r. So that's 8. Okay, our next one's going to be, we have one more example, 2 more examples. Number 2 is how much carpet do you need to fill the circle? Well, if this is 10 feet, the diameter is 10 feet, write down your formula, a equals pi r squared. And remember now, if the diameter is 10, the radius is 5. So you have a equals 3.14 times 5 squared. You could use the 22 over 7, just depends. And then you multiply it on out and you get that, and make sure to label it feet squared. Okay, third one. The center of a circle is at 2, negative 3. That's where the center is right here, 2, negative 3. Okay? Find the area. Well, when you graph this and see the graph of it, you see that that center to the end, remember that's called the radius. So how many is it? It's 1, 2, 3. So our radius is 3. Once you have the radius, you've got it. Just plug it in, square it, and you get the answer. This time our answer is unit squared because they didn't give us any inches or whatever. All right, one more big problem, but we can do it. Okay, find the perimeter and the area of the track. Okay, and they left out, they help you see that from here to here is 100 meters, and this right here is 62. But look at what you have. I can't draw it very well, but this is essentially half a circle, and this is the other half of the circle. So I have a circle and a rectangle. I've got to find the perimeter of it, I've got to find the area of it. Okay, so think about what you have in the big picture, and then you just boil it down to the formulas, and then you can get it very easily. You have a combined shape of one circle and the 2 long sides of the rectangle. So we have the circumference of a circle, and we have only the 2 long sides of a rectangle to find the perimeter of. Circumference is pi times d, so I just plug in my number. I know that's my diameter, because remember, if you had a circle, if I could put both those ends together, that would be my diameter. Okay, so I multiply that out, and then my rectangle very clearly is just the 100 plus 100. So you add that all up, and you get 394.68 meters for the perimeter. The area is very similar, same thing. I got two shapes, one circle and one rectangle. Now I have a whole circle and a whole rectangle I've got to find the area of. Okay, I have the area equals pi r squared, and I know if my diameter is 62, my radius is 31. So I have 3.14 times 31 squared, and that boils down to that number. The area of my rectangle is length times width. Well, my length I know is 100, but how do you get the width? Oh, it's the same as the diameter of the circle. See how that works out? And you have 100 times 62, which is 6,200, and then you add those two together, and you get your final answer. Okay, that's it.